This is question number 5, parts B and C from the 2.4 MyLab math homework. And in this problem, we're given a quadratic function. And in parts B and C, we're being asked to do something. It looks kind of familiar. B kind of looks like the difference quotient. And then in C, we're being asked to take the limit of that thing that kind of looks like the difference quotient as h goes to 0. So this should remind you of the generic difference quotient you've been seeing in class. So remember, if you want to find the derivative of a function at any point x, you can take the limit as h goes to 0 of this difference quotient of f of x plus h minus f of x all divided by h. And again, this is for any x, any input in the function. I can use this to calculate the slope of the tangent line for that x value. But what we've been given here is this. So let me write below so I can blow it up a little bit bigger. We've been given this. We've been asked to find the limit as h goes to 0 of f of negative 2 plus h minus f of negative 2 over h. So what this is doing is it just replaced my generic x with a specific value, negative 2. So what this is really doing is it's calculating the derivative for a specific x value, for the x value negative 2. Okay, so I'm going to walk you through the algebra. If that's not making sense right now, that's okay, because you can just use your knowledge of inputs and outputs and reading function notation to calculate B and C without understanding what I just said. But I'm going to come back to this idea that we're actually doing this generic difference quotient for a specific x value for the tangent line at x equals negative 2. So I'm going to come back to that at the end, but let's just go through the algebra. What is the algebra telling us to do in parts B and C? Okay, so what did B say? B said I'm taking f of what? The binomial negative 2 plus h. Then I'm going to plug a negative 2 into the function, and then I'm going to subtract those outputs, and then the whole thing is going to get divided by h. Okay, so what does my rule say? My rule says that when I input something into the function, the calculation is 8, that's a constant, minus whatever the input is, squared. Okay, well, let's just input the binomial, negative 2 plus h, into the function. When we do that, we're going to get 8 minus the input squared. And the input in this case is the binomial negative 2 plus h. Then I'm subtracting what? Well, in this next piece, I'm being asked to plug negative 2 as my input into the function. So again, the rule is 8 minus the input squared, and this time the input is a negative 2. And I'm going to put all that in parentheses just to guarantee that I subtract the whole thing. I need to subtract f of negative 2. This is the calculation for f of negative 2. It happens to be in binomial form right now, so I put parentheses around it. Okay, and all that's going to be divided by h. Okay, so let's clean this up a little bit. I see over here that I have a binomial square, so I need to go do the algebra for that. I'm going to do it to the side over here. So I have negative 2 plus h times negative 2 plus h, and you can distribute or FOIL, whatever you're used to doing, I'll distribute. So negative 2 times negative 2 would be positive 4. Negative 2 times h would be negative 2h. H times negative 2 is negative 2h. And then h times h would be h squared. And then I'm going to combine those like terms together there. So if I subtract 2h and I subtract 2h again, I'm going to subtract 4h overall. Oh, I forgot my little squared there. And then I'm adding h squared. Okay, so I'm going to go put that information back into this difference quotient. So what do I really have? I have 8 minus this trinomial replaces this binomial square. And I'm going to put the trinomial in parentheses because I need to subtract the entire result of the binomial square. So I need to subtract 4 minus 4h plus h squared. Okay, then I need to subtract the result of this thing. And since there's no variables, I can just simplify that down to a single number. So let's see. I'm going to do negative 2 squared. So negative 2 times negative 2 is going to give me a positive 4. And then 8 minus 4 is 4, and I don't need parentheses there because it's just a single value. It's a monomial. Okay, and all that's going to be over h. So now I need to clean this up a little bit. I need to subtract every single piece of this trinomial. So let's go ahead and do that real quick. So what am I going to get? I'm going to get 8. Then I'm going to subtract 4. I'm going to subtract a minus 4h. So that's going to add 4h back on. I'm going to subtract an h squared. And then I still have this minus 4. I can't forget about that. And the whole thing's still divided by h. Okay, so when I go to combine like terms here, if I have 8 and then I subtract 4 and I subtract 4 again, that's all going to combine to 0. Okay, so what we really have here is just 4h minus h squared all over h. Then I'm just going to factor an h out of that numerator. 4h has an h term that can factor out. That'll leave me just with a 4. Minus h squared has an h factor. That'll factor out. That leaves me an h. All that's over h. And then h divided by h is 1. So I end up with the binomial 4 minus h. Oh. Okay, so what does that even mean? That means this entire expression up here, this difference quotient looking thing, all of that simplifies down to this binomial. They're interchangeable, they're equivalent. Okay, and then part C, when we get to part C, I'm just going to take the limit of that thing. So instead of saying the limit as h goes to 0 of, that difference quotient looking thing. Okay, sorry, there's a little delay here in my app, so I'm just rewriting what C is asking me to do. Instead of doing all that, I can erase this difference quotient and just replace it with that binomial. So that's what I'm going to do. We just figured out in part B that that entire difference quotient is equivalent to 4 minus h. Okay, and anytime we're taking a limit where the input is going to a specific number, we just try plugging in that number, right? So we're just going to plug in h equals 0, and we'll get one of 3 cases. Case 1 says if you plug in the input and you get a number, you're done. That's the limit. If you plug in the input and you get 0 over 0, that's a case 2, and that just tells you have more work to do. You have to like simplify and factor and reduce, and then you plug the input into the simplified expression. And if you end up with, you plug in the input and you end up with a number over 0, that's a case 3, which says the limit does not exist. So let's see what case we end up with here. Okay, so I'm not using my limit notation anymore because as soon as I plug in that input, I'm finding the limit, so I don't need limit notation anymore. But instead of 4 minus h, I'm going to replace that h with the input. It's approaching 0. So I have 4 minus 0, and 4 minus 0 is just a number. So this is a case 1. We're good. That's my limit. That's my limit. I'm approaching that number. Okay, so that's the answer to C. But to connect it back to what I was saying in the beginning of this video where I had that generic difference quotient, and we noticed that the only difference from the generic difference quotient and what we were asked to do in B and C was replacing the generic x with this x equals -2. Let's just see what that even means. So what I'm going to do here is I'm going to take the derivative just using the power rule, like a generic derivative with x's involved. Okay, so my function was 8 minus x squared. I cannot handle the delay in my app right now. And then I'm just using my power rule to take the derivative. So I'm going to start with the 8. The 8's a constant, so the derivative of a constant is 0. And then I'm subtracting x squared. The derivative of that would give me a -2x. Again, I just use the power rule. And this is calculating the derivative for any x value. So what if x was equal to a -2? Well, my derivative better be 4 because we just figured that out in part C, right? So let's do that. Let's input a -2 into this derivative rule, this generic derivative rule we just got using our power rule. So my rule says I do -2 times the input I happen to be inputting a negative 2. Negative 2 times negative 2 is a positive 4. And I'm going to blow up this graph real quick so we can zoom in at x equals negative 2 and see if a derivative of 4 even makes sense there. So let me go ahead and do that. Okay, so here's our graph blown up a little bit here. And so here's negative 1, here's negative 2. So here's x equals negative 2. Okay, and then I'm going to come up. And I'm looking on the graph of this parabola here. So I'm going to the graph of this parabola. So I come up, I hit it right there, and then they've drawn in the tangent line at that point, x equals negative 2. And it looks like the slope could be 4 there. Let's see if they drew enough of this, if I could do some rise over run. If I rise 1, 2, 3, 4, and I run 1, I do hit my line, so it does look like a slope of 4 is reasonable there. So we just calculated that the derivative of negative 2 was 4. You know, I could put that over a 1 to get my rise over run, because derivatives are just instantaneous rates of change. So yeah, so it seems reasonable that positive 4 would be the correct derivative at x equals negative 2. It's the slope of the tangent line that touches the parabola at the exact point where x equals negative 2. Okay, if you have any follow-up questions on that one, just shoot me an email. I'm happy to help.